Welcome to Session 11, Prism and Cylinder Volume. We will build the idea visually, solve a complete example, and finish with a short independent check. By the end, you will be able to use the general prism idea, V equal BH, where B is an entire base area. Identify the congruent parallel bases of a prism or cylinder. Solve cylinder volume problems with radius, diameter, and unit conversions. Keep the diagram, the calculation, and the unit connected at every step. Start with the concept visual. Every prism follows base area times height. The A cylinder can ask for surface area instead of volume. Read every label as evidence about what is known, what is unknown, and which measurements actually belong in the model. Here's the central reasoning. A cylinder with diameter, 8 centimeters in height, 10 centimeters has radius, 4 centimeters. Its base area is 3.144 squared equals 50.24 centimeters squared, so its volume is 502.4 centimeters cubed. Every prism and cylinder uses the same structural rule, base area times perpendicular height. The base may be a polygon or a circle, but the repeated layer idea is unchanged. Draw or imagine a cross-section and decide whether you are filling the solid or covering it. This separates cubic volume from square surface area. Now add a precision check. For a solid, mark the base and the perpendicular height, then separate flat faces from curved surfaces. Keep pi or other exact values through intermediate steps. If the object is open, attached, or partly hidden, count only the faces the context says are exposed or filled. A complete line of work should make the diagram, formula, substitution, arithmetic, unit, and conclusion easy for another learner to audit. Use this repeatable method. First, mark one base and calculate its two-dimensional area first. Second, identify the perpendicular distance between the matching bases as the solid's height. Third, multiply B times H. For a cylinder, this becomes pi r to the power 2 hours. Finally, round only after all factors have been multiplied and label the result with cubic units. Do not skip the final check simply because the calculator produced a number. Let us model a complete example. A prism has base area 40 square units and height 3. What is its volume? Step 1 is to organize the information. Mark one base and calculate its two-dimensional area first. Step 2 chooses and sets up the relationship. Identify the perpendicular distance between the matching bases as the solid's height. Step 3 carries out the mathematics. Any prism has volume base area times height. 40 times 3 equals 120. A useful check is to base area is already area, so multiply by height once. The answer is 120 cubic units. Now verify the result against the original wording. The quantity, numerical size, and unit must all make sense together. Now it is your turn. A cylinder has radius 5 and height 4. Using pi equals 3.14, what is its volume? Write a formula or relationship before calculating, then use the next 6 seconds to finish your reasoning. The model answer is 314. Cylinder volume is pi r squared h. 3.14 times 5 squared times 4 equals 314. A useful check is to square the radius before multiplying by height. Use this coaching check as well. Separate the work into two labeled lines, base area and volume, so the squared radius is not forgotten. Session recap. First, mark one base and calculate its two-dimensional area first. Next, identify the perpendicular distance between the matching bases as the solid's height. Then multiply B times H. For a cylinder, this becomes pi r to the power 2 hours. Finally, round only after all factors have been multiplied and label the result with cubic units. A strong geometry solution is more than arithmetic. It identifies the requested quantity, represents the structure, calculates carefully, and checks the meaning of the result. Carry that full habit into the next session.